With that, we have Prashant Boyer here, and we're going to go ahead and start our session. Welcome, everybody, to the November 2021 Global Azure Data and AI Fest. We're going to focus on modern data warehousing. And again, we're virtual. Thank you, COVID, for messing up a lot of plans. But that's okay, right? I mean, we're able to get a lot more diverse portfolio of participants from different geographies. So this all kind of works out really well for the people who want to see events and really get good community content, but really don't want to drive and mess around in traffic. And we've got some great speakers today. So again, I'm Tim McLilly. I'm a Microsoft Senior Customer Engineer in the Northeast, sort of the DC area. And then I'll let my colleague Prashant introduce himself.
Welcome, everyone. Thanks for joining us. My name is Prashant G. Boyer, and I work as a cloud solution architect at Applied Information Sciences. So we're glad that you are able to join us, and hopefully you will enjoy the conference and also join us for the future conferences as well.
Exactly. Well, I'll go ahead and share the agenda, Prashant. We've got a good one. And again, we're focusing on Azure Synapse. Like we focused in June, we focused around AI and ML. So for this session, we're going to focus strictly on Azure Synapse. We've got a great lineup. We've got James Serra, who's kicking off our keynote here in a couple of moments to talk about Azure Synapse Analytics, an overview, and he's got a metaphor for a data lakehouse. And then we've got Malik El Kazan. He's going to talk about real near-time streaming into Azure Synapse Analytics. And then we've got Kevin Feasel with a session called "Where We're Going, We Don't Need Servers: The Serverless Sql Pool in Azure Synapse Analytics." And that's a funny take on it, but he's a very bright guy, but a good, nice sense of humor. And then we've got Jared Carney, how is Azure Synapse Analytics dedicated SQL pool different from a large SQL server, and he'll explain the MPP process. And then we've got our wrap-up session at 2 o'clock. Mark Price-Marr talking about dedicated SQL pools, a deep dive. And yes, you'll see this particular slide, right, Prashant? We're going to show this slide in between each session to answer questions around, hey, what's the next session? But also, will the session be recorded? Which I know all of you ask about, but we have a YouTube channel out at aka.ms at Azure Cloud Events. So all of these sessions will be posted out into our YouTube channel for you to watch later. We're gonna, as you know, Prashant and I run some user groups, and oh, that's a little typo there. But we had a user group. We have a user group. We had a user group on the 29th. That was our last one for the year. We've got this event that we're doing today. If you really want to know what's going on, go out to our Meetup Sites, and you can see I made a little boo-boo here. I didn't include, and I'll do it at the end. I didn't include, we have an AI ML user group, and then a global AI ML user group. For whatever reason, I didn't put those on here. Oh, here we go. If you want to go look at our events, like I want to see what all the events are, go out to our new website, Azure Cloud Events. You can go and see this event. And there aren't anything scheduled after this November 12th event, but we will pick back up on January 28th, 2022. That's the last Friday in January with the Nova Data Platform meetup. And I'm sure that Prashant will have some good content for his artificial intelligence and his global artificial intelligence meetups as well. And then, of course, in June 2022, off in the distance, we will have another Data and AI Fest. Hopefully it's in person or maybe a combo. We'll figure this out. Maybe we do a combo of in-person meetings and virtual meetings, whatever we can figure out, right, Prashant? All right, I'm going to shut up and I'm going to hand it off to an awesome speaker, Mr. James Serra, who's going to share at his desktop and talk to us about Azure Synapse Analytics Overview, a data lakehouse. And there's James. And James used to work at Microsoft. He's an awesome speaker. I've seen him present in person in front of customers, and I've also seen you present in front of, just user groups and stuff. So you're a great speaker. So off to you, James. Thank you.
Wow, what an introduction. You do all my introductions from now on. That was That was great. So welcome everyone to the Azure Data and AI Fest. I'm kicking off with the topic on Azure Synapse Analytics and Data Lakehouse, and you got some awesome speakers after this. So I'm going to focus on a high-level understanding of Synapse, and half of this will be presentations, half of this will be I'll jump into a demo. A little bit about me. As mentioned, I was at Microsoft for 7 years. I'm currently at EY for the last 9 or 10 months. I have a blog, jamesserra.com, where a lot of things I talk about today, I go into more detail on my blog site, so you may want to go there for more information. I've been involved in the SQL Server world since version 1.0 in 1989. I got involved with we'll call it the early version of Synapse. Started as a parallel data warehouse, an on-prem solution, and I was first hired at Microsoft to talk to customers about that. That changed to the analytics platform system. They just renamed it. Microsoft loves to rename things. And that got moved to, I should put a slide for this, but that got moved to the cloud called the SQL Data Warehouse. And then Microsoft renamed it to analytics, to Synapse Analytics, and added a lot more features, which I'll talk about. I won't go back to my DEC-VAX days when I was working on COBOL, but I've been in the industry 35 years and speak at a lot of the conferences. So we'll, as I mentioned, talk about an introduction to Synapse for the first half, and then we'll jump into a demo. Analytics, Azure Synapse Analytics GA'd, it's almost been a year now. It was in public preview for quite a while. It's undergone some changes. There's a link that I think they just published at the bottom here where you can keep track of what's new as it's rolled out into GA, and they keep adding features every couple of months. You can follow it on that. So what is Synapse, and what do I mean by data lakehouse? Well, think of at a high level, you have traditionally a data warehouse, and for many years, that was a relational database. We got into some of the technology, MPP, that I'll talk about in a minute. So you could have things like Netezza and Teradata, and then parallel data warehouse were MPP solutions that were all relational databases. Then this concept of a data lake came out about 10 years ago or so. And the idea of using data lake in place of relational database was a big failure. And people realized you need to have both. And so this is what Synapse does, is it combines both of those underneath the covers, you'll see, in what some people call, including me, a data lakehouse. It's the combination of a relational database and a data lake, but they're combined in such a way that it's very easy to switch between the two. In fact, you can use T-SQL to query data sitting in a data lake, as well as data in a relational database. Now, this is a little different than you may hear other vendors like that called data lakehouse, like Databricks. They call data lakehouse the data lake combined with Delta Lake, and not using any relational database. So that's their version of it. But in the Microsoft world, I'm calling it data lakehouse the combination of the two, just much easier to use together. So if we look at a traditional modern data warehouse, this is in the cloud. Before Synapse came along, you had different pieces that you would sort of plug together. You have Data Factory and Databricks and SQL Data Warehouse, and they all were separate tabs. If you think about it that way, when you're in Azure portal, you want to use Data Factory, it goes to Data Factory Workspace. SQL Data Warehouse was a workspace. Databricks was another one in there. So the idea of Synapse, that data lakehouse, is to have all of this under one single pane of glass on there. So you're not jumping out and into different workspaces. You all do it under one workspace, as we'll see in a demo. So this makes it very easier when you're looking to build data warehouses to do it all under Synapse now, because all those tools are underneath one portal for you. If we look at this with, this is to help clarify, a lot of people got confused, especially early on, with the naming conventions. Microsoft came out and they called it Synapse Analytics. They just renamed the SQL Data Warehouse. But they also, this was early on, had a newer version of Synapse that had additional features. The Synapse Analytics of old was simply the dedicated SQL pool, what it's called now. That was just a relational database, which continues under the new Synapse, but it has a bunch of other features that Synapse Analytics has. But the relational database, that dedicated SQL pool on there, has a lot of features that have been updated. It's got stuff in public preview and private preview. This is a little old, so some of this may be GA now. And that can continue to involve that one piece, but that's a piece of a larger solution. When we look at what's in the new Synapse Analytics, is a lot of other features that are listed here. So breaking that down into a diagram that hopefully makes it easier to understand is the new Synapse, you have everything under a workspace, that single pane of glass. Underneath that single pane of glass, you have pipelines and mapping data flows. This is Azure Data Factory, but it's not called that. It's called pipelines and data flows underneath there. But this is underneath that workspace. You have multiple ways of storing data inside of this. You have that relational database, that dedicated SQL pool. You have a data lake that you can store everything into. You have Spark tables. So this is brand new in analytics. When it went from the old version of SQL Data Warehouse to the new one, this is what they've added, these tagged a new here. One of them was the ability to create Spark tables on there. And then also is the ability to store data in Cosmos DB and link it into the Synapse on there. So with these 4 storage devices, you have multiple ways of accessing them via compute. We have the dedicated SQL pool here, which can go against that relational database on here. It can go against the data lake using external tables if you need to query it that way. The new version, this is really the most impressive thing that we'll have deep dive at later today, is the serverless SQL pool. This allows you to query data sitting in the data lake. It can query data sitting in Spark. It can also query data sitting in Cosmos DB. So you can actually have a federated query that queries all 3 of these tables and not have to move it into one central location. And this is being expanded. There's possible of a lot of other links, including one that was in preview right now to SQL Server, which I'll talk about in a minute. We also have in Synapse Apache Spark pools. This is new too, in that I can fire up a notebook, Apache Spark notebook, and I can connect to any of these storage devices too. So if I'm within this environment of building a data warehouse and I need to use Spark, it's just one click away, staying within that single pane of glass. And then underneath all of this could be Power BI, where I can use that to connect to the storage through a couple of all these 3 different means. One of them being serverless pool. So what you can do, which is really impressive, is I can say, I have data stored in the data lake. I'm going to create a view on top of that using regular T-SQL. I'm going.
Can someone, I think we're not seeing the screen right.
We lose a screen share on my end?
Yeah.
Let me try it again. There we go. Is it back up?
There we go. Yep. Good to go.
Okay. Strange. So we can put something in the data lake. So we have a bunch of files in there. We can use a SQL serverless pool to access that data using regular T-SQL. And then Power BI can call that SQL serverless pool to access data in the data lake. It'll appear to the end user you're hitting a relational database, but really you're hitting data in the data lake. And because it's serverless, you're only paying per query on there, so it could be much cheaper. So this opens up a whole other new world of possibly getting away with not using a relational database. There are trade-offs at the whole other presentation, but there's a lot of power in this serverless SQL pool now. They probably should have called it Power Serverless, would probably have been better. So this is it at a very high level on there. And jumping to what this now, the modern data warehouse looks like now, there's a lot of options. I break it out into these 5 stages. You have ingest stage, which you can use Synapse pipelines, that's a data factory. Now you can explore the data. You have options. I can use the serverless I just mentioned. I can use the pipelines and data factory, or I can use Synapse Spark and then to transform it, we have now 4 different options. And then to model it, we have a couple of different options in there. So what you want to do is understand Synapse, understand all these options, and choose what is the best for your particular situation based on the data, the size, the type, and the speed of that. And then cost becomes a factor. And there are multiple trade-offs that you have to be aware of in there. But the great thing about this is all these different options are available now that we never had before, and they're all under one package, one single pane of glass. The big thing is the Serverless Sql Pools, which opens up all over the world. On using data warehousing on there, it is pay per query on there, and it has the ability to auto scale up and down on there. And obviously, you're only paying per query, so when you're not using it, you're not being charged, which is a big difference in the dedicated pools, which once you turn it on, you're being charged for that. And currently, there's no auto scale for that or pausing. And so I also wanted to point out, even if you're using this, whether you're using a dedicated pool or SQL serverless pool, and I talk about the single pane of glass, you can still use SSMS or Azure Data Studio outside of that if you want. So you're not locked into just being inside the portal. So those of us who are DBAs like me for many years, love SSMS, you can still continue to use that. So the different scenarios that opens up with the serverless now is just basic data exploration. You'll see in the demo, I can just quickly and easily use this serverless to query data sitting in a data lake and just see if it's got value. And maybe I want to move it from there into a relational database, but within moments, I can query those files compared to the time and effort it would take before, which was also costly. You can now create this logical data warehouse. As I mentioned, you have federated queries. Now you can keep data where it sits. It could be in Cosmos DB, a data lake, and a Spark table, and I can query that without having to move it into a central location. And it also opens the world of data transformation. So I've started to see customers who, they love T-SQL and they want to do everything in T-SQL. I can now use serverless and T-SQL against data sitting in the data lake. So maybe I land the data in a raw layer in data lake and I want to clean it, and I want to use regular T-SQL for that. I can do that. I can query it, transform it, and then write it back out to the data lake, all using the serverless pool to save its cost savings in there, and allows me to continue using T-SQL. And I will mention a couple things, or one thing here, because usually people have questions, well, can I use serverless against a relational database? Not currently. So that's in the next version of Synapse, and it's been announced quite a long time ago. It's in private preview. Don't know when it's going to be public preview, but the idea is when that comes out, we'll have this serverless, and the serverless will have the ability to go against a relational database and auto scale and pause, and as well as other things in there. But that's a conversation for another day when that eventually goes into public preview. And it also has multi-master clusters, which is a really cool feature that you'll learn about which was demoed before, which allows you to use various compute options on the same relational database, which you can't do right now. Right now, the dedicated SQL pool is a one-to-one relationship. One-to-one relationship between a compute and a database. All right, so just a quick intro to massively parallel processing on this. Again, this is something that was brought up many years ago with the Teradatas and the Teasas and the parallel data warehouse. And the way this works is different than the SMP. So that's your typical SQL Server way of processing data on there. It's a scale up, and you reach a limit, and you get a new server, and you move everything over, and you have higher limits on that. That's an SMP. And even within the cloud world, if you're using, say, SQL database in there, there are tiers you can go up and up. But at some point, you can reach a limit on that. And with MPP, is it scale out? It's I can add additional CPU onto it and not have to back up and restore it on a different server on there. It scales out, and I'll show this in a slide in a second. And this allows a tremendous benefit because of the ease of use of scaling things up. It's literally a sliding bar on there. So you get massive performance without having to do anything with your database. So if we look at this at a high level, you have in Synapse, in the dedicated pools, a control node, and that's the public interface. Behind the scenes is various compute nodes. Each of those compute nodes is using storage on there. So you can think of the control node as the worker bee, the control node as the brains, the compute nodes as all the worker bees that get scaled up and down. And the data movement service is kind of the secret sauce of what's different about this than regular SNMP. And you'll see in the query plans a little bit of difference in the way it works when you scale things out on here. But when I've introduced this to DBAs, usually you spend a day or two and they understand the differences because there are some understanding of the query plans and the way the data is laid out that you need to understand, but it's pretty minimal. So if, as an example of this, if I have a query, I'm gonna connect to that control node. The query plan is gonna parallelize that query and run it on multiple compute nodes on there. Each of those compute nodes has a subset of the data, and it runs that query on that individual compute node, and then it passes back the results and smashes it up and sends it back out to the end user. So they're not aware of all this complexity going behind the scenes. It does this automatically. And because it's got multiple compute nodes, different pipes on there, it runs a lot faster. An analogy that's a customer gave me many years ago was, it's like having a deck of cards and you're trying to look for the ace of diamonds on there. And if I have one person, I turn over all the cards and it could take me a while to find that ace of diamonds. And if instead I get 26 people and I each give them 2 cards and ask them to find that ace of diamonds, it's going to find it a lot quicker. And that's what you think when you scale things out. So the big change when you go to this environment is the way you lay out the data. So, and typically in a data warehouse, you go from third normal form to a star schema on here. And the star schema has a large fact table and dimension tables. And the way this works is the dimension tables are replicated to each of these compute nodes. And you can do this because dimension tables are small, there's a lot of space, and it's relatively cheap. So you can replicate those dimension tables to each of the compute nodes, because the idea is if I didn't do this and I wanted to join the dimension table with the facts table, which is you always do, is I'd have to shuffle the data around, because you can have parts of tables, dimension tables all over the place. And that could be costly and slow to move all this data around, because you can talk about multiple petabytes on there. So instead, it replicates the dimension table, but splits up the fact table into smaller pieces. So when I push down those queries into each of those compute nodes, it's able to join all that data together without having to shuffle the data around. And that's how you get this huge performance increase on there. And what you need to learn is how to distribute this data. There's different ways, there's hash table, round robin, but it's pretty straightforward. And once you figure it all out, you can make the layout so queries will run anywhere from 20 to 100 times faster. It's really impressive how much faster queries can go in an MPP solution. And behind the scenes, this is what you do. This is the only difference is you're familiar with the create table, you'll have this distribution keyword in there and define how you're going to distribute the data. And once you execute this create table statement, it goes to the control node, which has the metadata of that table, and then it sends the create table down to all the various compute nodes. Each of those compute nodes can then split up this fact table on there, and you can even go to the point where you can partition it if need be. Usually you don't, because it's fast enough without that, but that's the way that works. So it's not like you have to learn a lot of new ways of doing things as a DBA. It's just simply adding this distribution key. And then what you can do with the data warehouse is we have this thing called the DWU, data warehouse units. It's literally a scaling system on here. So instead of having to know how much CPU or RAM or IO I want to adjust, I don't have to worry about those. I can just scale this and I will automatically get more CPU, RAM, and IO. And it's pretty linear, meaning if I at my DW 100 and I go to 200, I'm going to double the performance. And 200, 400 double again in there. So they have all the way up to the 30,000 on there. Of course, it costs more. You can see how much it is as you move the slider up in there. And then once you execute this, it takes about 2 or 3 minutes and you have this new performance. Compare that to trying to upgrade something on-prem. That's a whole nightmare. I've been through that many times, and this makes it so much easier. And I think they even have it generally under a minute now, where it'll upgrade the tier for you. Now, currently you have to do this manually, or you can write some script to do it at certain times. Like say on the weekend, nobody's going to be using it or rarely being used. I'll scale it down to DW100, and then maybe Monday morning early, I'll scale it back up again there. Coming in the next generation will be auto scale and auto pause, but right now you have to do those manually or via script. The architecture underneath the covers for this is I have 60 distributions of that data, so that's fixed, and it's fixed this way. It doesn't have to move the data around if you change tiers, which could be really time consuming on there. So it fixes that 60 blocks. So if I'm at the lowest level, like DW100, I will have one VM that's going against the 60 distributions. If I go to say DW600, I will have 6 VMs going against 60 distributions. If I go all the way to the max, I will have 60 VMs going against 60 distributions, so it's a 1-to-1. Now, that's the way it currently is. They could always change that, Microsoft, and have different numbers of VMs, but that's the way it works. So I just wanted to give you an understanding of how it's able to scale and get performant, is because the distribution numbers are 60, which could change too.
We can't hear you, James.
Oh, we lost your sound.
Wow, this is weird. It's like Gremlins. For some reason, it went mute. So you can hear me now, right?
Yeah.
Yeah. All right. So strange. I'm blaming Microsoft for problems with Teams.
That's
So
right.
just thanks for letting me know what else pops up. All right. So let me go to the demo on here. This is a retail demo. If you want to build this demo yourself, you can go to this link, and the code is all there that you can run, and it will go into your Azure subscription and create all the scripts, the code that you're going to see. It'll create the data and all that. So it's a great, cool way to quickly build out a solution that you can play with. And so what you'll see is all based off of that. This slide here is giving you a high-level overview of all the options you have within Synapse. I have 4 storage, as I mentioned before: relational, data lake, Spark, and Cosmos. I have different compute options: dedicated SQL Pool, serverless SQL Pool, or I can use Spark. Not all of them work against all the compute, so I laid it out here, where you can see some of them are supported, some of them in the future on there. And I will go through some of these options so you can see them in play. The one on the right, which was just announced at Ignite, was a Synapse link for SQL Server 2022. This works a little differently. They call it a link, but it's not really a link in that, compared to the way it works with Cosmos DB, where it's a link to Cosmos DB. I can query and go out and get Cosmos DB and pull it back into Synapse. With Synapse link for SQL 2022, and only works for 2022, is any changes to SQL Server automatically get replicated into a relational database inside of Synapse on there. So it's not quite the link as the other ways, but it does allow you to query SQL Server 2022 without impacting the source system. And then the table below that is the objects that are supported within Synapse. You can see there's Parquet, CSV, and JSON, and then there's various table combinations. Some of them you can right-click, and there's a preview button that I'll show you on there that you can use. You can also use a SQL script as an option when you right-click it, or a new notebook, which is supported for everything, but some of the preview are not quite yet supported on there. All right, so jumping over to, there's some questions that were answered. I will take questions. I'll pause in a little bit for questions if people want to come off mute or type it in the chat window. For right now, I'm just going to get started. and show you at a high level the way Azure Synapse works. So if we look at the portal for Azure here, I can simply just go in there and type Azure Synapse, and Synapse, and it comes up here. I click on that, and it goes in there, and it shows me my workspaces I've already created here. So I simply go and create a new workspace. This is just like a holding area for everything on there. So there's not much to put in here. And once you do that, you create this workspace that'll become your single pane of glass. If I look at one of them I created before on here, one thing you'll notice is I have these SQL endpoints that are created. So if I want to use SSMS, I would just enter that data as connect to it, and if my security is set up, I can use SSMS. In this demo, I'm going to jump into the portal and do everything through that instead of SSMS. The one thing you'll want to do right away when you create this workspace, which just takes under a minute, is you want to say, well, I want to create some SQL pools, relational dedicated pools on there. You'll see there's a built-in one, that's the serverless one, that's there automatically. I created a couple other ones in here. So this looks like, if you're familiar with SQL Data Warehouse, it's the same thing. I'm creating a dedicated pool, and it's a one-to-one relationship, again, a relational database with a compute. And this is where I set up the pool name, which will be the database name on here. There's a few extra settings where I can restore it from a previous backup, and that's about it. And then after a minute or so, you get a dedicated pool on here with the database assigned to it. And then you'll see on here, I can pause it, I can scale it up and down, and that's all controlled manually through this or through scripts. The other thing you're usually going to want to set up is some Spark pools on here. And I've got 4 set up, and this looks a lot like Databricks, if you're familiar with that. I can come in here and say, I want to create a pool. I want to choose the size of the pool. You can see it goes all the way up to 64 cores. I want to enable or disable auto scale, and I can choose how many nodes are going to be used when I scale it up and down. If I go under additional settings, I can auto pause it after a certain amount of minutes I specify. And then here are the versions of Spark. It's 2.4 is default, but you can go to 3.1. And there has Delta Lake support 1.0 on that. So you do all this, you can create, and it just takes under a minute usually for that, and you can create multiple pools with different sizes, because maybe certain people, you want to give them permission to use the really large one, but control how many people can access that. And you want to give other people access to smaller pools, or depending on what type of queries and reports you're running. But so you have a lot of options on here in choosing that. And the beauty of this is it auto scales up and down and it auto pauses. So create as many pools as you want. You don't have to worry about you're going to blow out your costs because all these pools are running and you forgot to shut them down. Once I do that, you can go back to the overview here. You see this Open Synapse Studio. And if we click on that, it jumps to that single pane of glass. So you'll never have to leave this single pane of glass once you're in here. And you'll see some things to get you started on here. There's an ingest piece. So if I click on this, this looks like Data Factory on here. So there's a built-in copy task. And if I look at that, it's going through a wizard, just like in Data Factory, where I say, what source type am I trying to get something? Maybe I'm trying to get something from Data Lake or Gen 2. Did I previously connect the connection, or do I need a new connection on here? And this is, if I pick a new one, you enter all the parameters in there, and then you'll get a connection you can use over and over again. And then it specifies all the parameters you want to use in pulling out data from that data lake on there. And then you go in there and you specify the target. Same thing is, maybe I'm pulling from a data lake and I want to go to a relational database. And then I put that in here, that it's going into the database, a dedicated pool, say, and there's the connection for it. And boom, I go and do all this, and I run it once, or I schedule it to run many times. And then what you'll have is, if I go to back to here, and if I go to the ingest piece, the integrate piece on here, you will see that I have, in this case, I would have, if I created it, I'd have a copied data statement with all those parameters that I previously entered in the wizard popped in here. And so it's a quick and easy way to get started. Maybe in this case, I'm copying data from SAP HANA on-prem into the data lake. And maybe I copy it to the data lake, and then I also want to transform that data from the raw layer in the data lake into, say, a clean layer. This is where I can use the data flow. So again, this is what you'll see in Data Factory. I have the ability to come in here and create all these steps. If those familiar with SSIS, this is like a much improved version of SSIS in the cloud. And I can then transform all this data. And they have a lot of cool stuff in here and make it very easy. I can go in here and I can use the expression builder, and I just pick what I want to do, and I populate stuff in here. They've made it really easy. There's even things like if I look at the join, it's got these nice pretty pictures of what full and outer and inner and all that. So very quickly and easily to build these transformations. Now, interesting, when I execute this, what it does is it transforms these tasks which are in JSON into Scala, and it runs it on a Spark cluster on there. So I always tell customers it's like a pretty interface over Spark on that. And so a lot of customers will do it this way because it's very visual and easy. Now, if it doesn't have all the features, or maybe it's not as performant you want, you can go into the Spark, which I'll show. But a lot of customers, this will do fine. One thing I want to show is the manage. If I go into manage on here, I have this link services. This is where I create links to everything. So I was using the data lake in there. Well, in order to use the data lake, I have to first come in here and I link to it. So if I go to new, I choose what I want to link to and the configurations, and it pops it in here. So you'll see I'm linking to also Power BI, Cosmos DB, and this will be enhanced to have other things in the future. But right now, it's really cool that you can link all this into your portal, and once it's in here, you never have to leave this tab anymore. Everything can be done within it. Now, you could still do things outside of it. So if I link to Data Lake Store Gen 2, I can do things in the portal, but it's also available through the other functionality in the Azure portal. So it's linking to the same thing in different ways to access it. There's also, I'll mention Git integration here. So if I wanted to connect to a source code repository, as I go along, everything I'm doing in here, I can create a work branch and publish it all to that. And so right now you'll see I'm live, but I could have set up a code repository for that. So this is a really cool feature to have source control. All right, so going through a little bit about how we can query data. If I go to the data tab and I hit on linked on here, you will see these are the things I linked to on a previous tab. One of them is Data Lake Store Gen 2. If I open this up, you'll see I have folders in there. And inside one of these folders, like I'll go to the custom Parquet, the Parquet files that were dumped in here. Now, if those familiar with trying to access data before Synapse, it was a pain to run queries off of something sitting in a data lake. Available was Databricks. So you'd have to create a Databricks cluster. You'd have to open up a notebook. You'd have to attach to the data lake, which was a whole pain in itself. And then you'd have to run some query using a language you may not be familiar with. You can use Spark SQL or Python, and it's a little different. It's different, or radically much different than T-SQL, which was also troubling to many people. So it was a long process. Right now, the way you can do it within Synapse is I can right-click this. You'll see New SQL Script. I can select Top 100. And if I run this, you'll notice it's using the built-in option right here. So that's the serverless piece. And it ran. And within a couple of seconds, 4 seconds, I queried that. The magic is this open row set where it points to the file that I wanted and it queries it. This is regular T-SQL, so I can expand this with a where clause. I can even say, well, I don't just want that one file, I want all the files in there. So if I were to change that, I can run it, and then I get all those files that's sitting in that folder on this. So man, this is such an improvement over doing it in the Databricks notebook. on here. And I even have charts in here that I can open up and get some quick results on there. So imagine if you just need to explore some data, how quickly and easily it is now. All you need to do is dump the file into a folder and go into Synapse, and I'm using regular T-SQL against those files. Now, if I were to make this a view and save it, it saves it in the serverless. The serverless it's a database, but it doesn't have any data in there, but it can hold views. And once I save this in here, I can call that view from, say, Power BI, and it's going to return as results. It's going to be cheap because it's pay per query, and it's going to look like a relational database, because in here I can put the metadata that defines the columns. Otherwise, it pulls out what it finds in there, so you can see it does a good job of that. But if I wanted to change those names, I can just change it within the view, and nobody's the wiser that it's hitting a file sitting in Data Lake. I can even move that data into a relational database and just change the SQL to point to the relational database without having to change all the rest of the code. So it's easy to move data back and forth because of that. All right, another one is if I come here to CSV, I can right-click this. As I mentioned in the preview, if I right-click this, there's a preview in here, and you'll see, boom, just like that, I have an insight into what's inside this file on that. And I can see if it's got value and if I want to do things with that. So that's a real cool feature that they added. If you then say, well, I really want to use this in Spark, I right-click it, I go new notebook, and I go load to data frame. And it puts the command in there to access that data for me. And then I choose the Spark pool I want to use, and I run it. Now I'm in a Spark notebook, but I didn't have to jump out into another tab and have a lot of trouble creating clusters and all that. All that stuff is much easier to do. And you'll see I have various different languages I can use in this Spark notebook. If I click on the settings, I can adjust what's being used. I won't get into it, but there's a lot of, like the executors, there's a lot of tweaks you can make the things run faster or save costs and such. And this, the first time, could take a minute or two because it didn't warm up. Once it warms up, and you can specify how long it stays warmed up, that'll be around. So anything that you execute after it will run really fast. All right, so let me jump into a couple of the things on here. If we go to the workspace, you'll see we have the SQL database and we have the SQL pool. So this runs just like you're familiar with relational databases on here. If I go in here and I pop open, say, sales, and I right-click that and do new SQL script, now I'm running this in that MPP technology, and it's using it's a one-to-one relationship, so I'm using the pool which has the SQL pool database on here. And this usually takes about 5 seconds. The demo gods are making it run longer with me. And this also gives you some warm-up capability, so things will run a little bit faster once it runs the first time on there. And I don't know why it took 23. And this is so next one it ran instantaneously. And this is at the lowest setting. So if I run it at DW100, if I run it at 1,000, it'll be 10 times faster. So that's probably the problem. I lowered it to save cost. Other things that are cool to look at is if I go to the develop here and I go to Sql Scripts on here. So I have notebooks that I can save on here. So I've opened this up. You'll see all that code is tracked in here and the results of what I ran last time on here. If you look at the Spark table example, I can come in here and I can create a database and a table within here that creates a Spark table on here. And that Spark table, if I go back to data, you'll see it under this, what they now call a Lakehouse, lake database on here. It used to be just be it had a different name to it. So again, they're renaming things, but they call it a lake database because the data and the metadata are all stored together. And so you'll see it underneath here. So the one I just created, if I open up here, you'll see this is a Spark table on here. And it has all the metadata attached with it. So it allows me to easily interface with a table that I stored in Spark. Now, the cool thing too is if I create this in Spark here, and I want to access this table, I can actually access it through the serverless pool. Even if I shut down this Spark pool, I still have access to it. So it's a really cool feature that they made in that the metadata of this is copied over to the serverless pool and it's aware of it and it can run queries against it. So create something in Spark pool. You don't want to use Spark pool, shut it down, go and use it in the SQL serverless on that. So that's a great way to allow you to use T-SQL against something that was created in Spark and also use serverless so it's saving costs.
Hey, James. We have a lot of questions. Can we, let's kind of start at the front range of the questions, and then if we have time, or I just want to give you time for the answering questions because it seems like we have a few of those.
Yeah, sure. Let's jump to questions now, and time permitting, I can show a few other features, but I know people can be a little bit confused at this point, so let's hit them.
Okay. We'll start with the first one here, and I'm going to skip past one, but and if it doesn't apply, just kind of skip past it. We can answer it later. But can you describe the security authorization involved for querying the data lake store from Synapse? Or is that maybe too broad?
Just to quickly hit is it uses RBAC. So anything you define when you create that storage in there, you can choose through RBAC who can access that, and that security is used within Synapse on that. Okay. So RBAC is the answer to that.
Okay. Depending on the time of day, during heavy usage, can I increase or decrease the number of nodes?
If you're talking about the SQL pool, as I mentioned, there's that slider bar on there. So right now it's manual to go up and down, or I've seen a lot of customers create some script that'll do it after hours, or I've seen some people get fancy and automatically adjust based on tracking the queries that are being run in the CPU utilization. That will be much easier to do when the next version of Synapse comes out, but for now it's more of a manual process.
Got it. I didn't see the Delta Lake on the diagram. Is that needed at all for analytics performance? And can the serverless SQL pools query the Delta Lake?
Yeah, it can query the Delta Lake. That was added a couple of months ago. And the Delta Lake is a abstract layer on top of the data lake that gives you additional performance like ACID compliance and faster performance and ability to do upserts and deletes. And it also has some other features to it, like time tracking. So you can see the data as it's changed over time. It tracks all that, and you can go back and say, tell me what this data look. I'm gonna run a query based on what the data looked like yesterday. So it's all these features on top of that, and that is usable through Synapse. That was originally came through Databricks, but they open sourced it. And if you saw early, we support version 1.0 of Delta Lake now.
Gotcha. Thank you. Does DWU impact the number of worker nodes? And then if yes, then will data get rearranged for the facts and replicate all the dimension tables data?
Yeah, the DWU just strictly, as you move that up or down, adds or deletes virtual machines. The data is over those 60 distributions. That never changes. So that's why you can scale up and down within a minute or less, because it's not having to move the data. So that just means you need to be careful of the way you find the hash keys that lays out the data.
Yeah.
Because that's not going to change. And so that's where you spend a day or two, if you're familiar with SQL Server, to learn about that distribution patterns. And then you're all set.
Yeah. And then a little follow-up around that question. So for customers, the DWU is hard to comprehend and relate it to the actual performance figures that are known for a more traditional compute environment. Is there, and we can find this out too, James, is there information about DWUs? Oh, maybe a link or something like that.
Oh man, that's a question that I've heard from day one. And actually the same question came with SQL database when we had the same thing, DTUs. And hey, look, you don't have to worry about CPU and IO and all that. Well, people pushed back and they said, I want to know about that. I don't want that to be abstracted out on there. And so they changed the model in there so you can, in SQL database, you can choose the CPU's usage on there. You see all that. They haven't done that with Synapse. It's still DWUs. Right. I haven't heard if they're ever going to change that. So it makes your life easier, but people didn't want that. So that's why I hear that question a lot. But right now, you can probably get from Microsoft behind the scenes what the CPU levels are using. I've seen that before, but that could change at any moment. And it's, again, if you think of it's being linear, if you double the DWUs, you're going to get double the performance. But understandably, reach out to your Microsoft representative if you want to know details on the CPUs that are being used.
Gotcha. Can I configure row and column level security here?
Yeah, you can do it. And there's a whole thing on row level security and workload management that you can configure. In longer demos, I go through that, but you can do the row level security on here as an option on that, or you can do the row level security in Power BI. That could be a whole other topic too. But that is available.
Does this integrate function work with DevOps in the same way as ADF does? Does it tie into DevOps?
Yeah, that's where I showed you the Git integration on here. So you can create a workspace like you do in Data Factory and save it to that workspace and then promote it when it's ready to go. We can get the other questions. I think we're good for now. Okay, well, I just got a few minutes left. I just wanted to jump and show you a couple other, one other cool thing is if I linked in Power BI, like I showed you before, I can come in here and I can then start using the Power BI workspace that I linked to. So I can create data sets, I can create reports. If I open one of these up, you'll see it looks just like regular Power BI. So this is a great way to test out what you're building. This wouldn't be to create reports in production because the person using this will be the DBA or the developer, and they're going to use this within Synapse. You wouldn't have regular users go into Synapse and use it this way. But I can create ones here. I can even publish it out the workspace that they can use. But this is sort of a quick and dirty way to start dragging fields that you've created inside of here with a dedicated pool or a view on a serverless on a data lake on there and generate Power BI reports that you can use to validate the data. Create reports as a starting point on that. We also have in here, I mentioned the federated query approach. So I can create views on top of, in this case, a data lake. I can create a view on the Spark table. I can create a view with Cosmos DB. And then I could run a view that uses those other views. And so this is an example of how I can query all this data and not have to bring it in a central location. And this is very fast. When I run this, usually it takes just a couple seconds on here. So this is where you start getting in the world of, well, maybe I don't need to put everything into a relational database. The trade-off is it's not going to be as fast. You don't have MPP technology. You don't have things like role of security in a data lake like you have in a relational database. So you have to be aware of those trade-offs, which I blogged about. But this can open up a whole other world of quickly and easily querying data and saving a lot of costs on it. And then the last thing I'll mention, because people are kind of hidden, if you go to data and you click on this plus, you'll see this gallery. If you go on this gallery, you'll see there are sample data sets you can pull in here, sample notebooks, sample SQL scripts, and sample pipelines, ADF pipelines that you can use to quickly get started. And something they just added is database templates. So I have predefined tables, previously known as common data models. Again, they changed names and they call them database tables, but they're common data models you may be familiar with outside of Synapse. And if I click on any of these, like banking, right now there's, what, 8 of them, and they're going to add more. But I have predefined tables on here that I can use. These are common data models. And so another quick way to build a solution is to use one of these database templates and pull from a source and map them and land it in here. So a really, really cool new feature. It's all visual, which is awesome on here. So I can start with a template, but then I can customize it, modify it, create my own templates in here. So really awesome new feature that I think is going to be really popular. All right, so with that, I have reached the end. So if you have any follow-up questions that I didn't answer here, feel free to shoot me an email. It's right there. Happy to answer them. My blog has more information about it. If I don't know if you're distributing the deck, but if what I'll do is I'll upload it in the chat right after this, so you have it that way, or you can email me and get a copy of it.
James, thank you very much. That was a great session and a lot of good Q&A. Guys, if you have additional questions that didn't get answered, we'll try to get them wrapped up before the day's out. But thank you again, James, for a great session.
Yeah,
yes,
thanks for
absolutely.
inviting me. And you have some great speakers coming on to dig more into this, so I'm excited to watch some of those.
That's right. And then connect to James over LinkedIn, email James, or add James to your Twitter account. And also, what we use here at Microsoft is his blog. The man can write some good SQL or data platform articles. So go out to the James Serra blog site for just a number of different topics. So kudos on your blog overall, and absolutely for the session. Thank you very much.
Yeah, sure. Happy to be here. Thanks for inviting me.
All right, guys, I'm going to stop recording, and then I'm going to share my desktop, and we'll go on for a little bit of a break before the next session.